So hello everyone, this is lecture 1 for the nuclear physics. In this lecture we will discuss only the syllabus part, and there will be 5 sections for the nuclear physics and 1 for the particle physics. And in it, first we will study about the basic properties of the nucleus. Inside that there will be nuclear mass, nuclear radius, nuclear mass, number density, stability and the binding energy, nuclear probes. This is kind of experiment in which we will study about the charge division, means with the help of the nuclear probes we can study the charge distribution inside the nucleus. And in all these processes we will study mainly the mirror nuclei method. And then we will see the radioactivity, rate equation for one step and the two step processes. So you already know what is radioactivity, so we'll study in detail about the radioactivity, half lifetime, mean lifetime, successive decay, A to B, B to C, radioactive equilibrium, secular and the transient. So these are the things which we actually observe in the natural world. And these results, now we are having these results, so there will be some model which actually define these results, means these results should be described by some model of the nucleus. That's why we need to study the models also. So after that we will study the nuclear models. Inside we will see that liquid drop model first, then we will see the single particle shell model. So these are the famous two models. And in the cell model we will see the spin, magnetic moment and the electric equidipole moment of the ground state of the nucleus. And then there was some properties which wasn't explained by the cell model itself. That's why there will be some third model, that is collective model. It's a mix up of all these. And inside we will see the vibration and the rotational model. So we'll see the nuclear models, then we will go to the nuclear forces and we will study out the general properties. Then we will go to the deuteron problem. Inside that we will study the strength of the nuclear forces, means after studying the deuteron we will get the idea of the strength of the nuclear forces. Single bound state we will find that, and then we will study about the spin of that, then magnetic moment and the electric quadrupole moment. So after that there will be section 5 for nuclear reactions. So we know in the nuclear reactions the energy will be emitted or absorbed. So and then we will study about the Q value inside that reaction of nucleus. And we will study about the fission and the fusion. So you already have the basic idea, so we'll study in detail about that. After that we will study about the particle physics, and inside that there will be classification of different particles: photons, leptons, mesons, nucleons, hyperons and heavy baryons. We will study them separately. Then we also discuss the quark model also. In the today's modern physics there is this quark model also. Then we will see the interaction of these particles inside the particle physics. Interaction can be strong, weak, electromagnetic and the gravitational. So we'll avoid this gravitational one because there is no gravitational some like thing inside the small particles, because they have very small mass and there will be very less effect of gravitational force. That's why their major part will be strong, weak and electromagnetic. Then we will see the selection rules: lepton number, baryon number, Strange's number, isospin parity. Inside the parity we'll see the time reversal and the charge parity. So this will be the syllabus for the particle physics. And there will be also, we'll study out the alpha, beta and gamma decay in the radioactivity itself. And most of the question asked from here: radioactivity and alpha, beta, gamma decay and the particle physics. So these are the major portions or the important parts from where the question can be asked. It's particle physics and the alpha, beta, gamma decay, radioactivity. So very less questions are asked from these sections, but mainly these are the important parts. If you wanna, I can suggest you some books. So you can study the Arthur Weiser, that is Concept of Modern Physics. You know about this book. And the last 3 chapters are means you can use this book for the last 3 chapters, and they will be helpful for your syllabus. And if you wanna study the nuclear physics, then for the interview purpose, the S.B. Patel, Nuclear Physics by S.B. Patel, that will be the best book for the interview purpose and the complete nuclear physics concepts. So I will recommend you to go through these, and you must go to the previous year questions for the NATGATE and TIFR. You will get the idea that what kind of question is asking. So that's it for today. From tomorrow onwards in the next lecture we will start with the basic properties of the nucleus. So thank you everyone.